All the shear and moment diagrams for the beam. To begin, we're going to convert our distributed load into point. So we're going to have it as W times L over 2. And then we have a roller at C and a pin connection at A. Horizontal at A is going to be 0. The horizontal reaction I'm referred to. Okay, and then we can find our AY by taking moment about the point C. We're going to have counterclockwise W times L over 2. And it's L over 4 OA. And after that, we have clockwise AY, L distance away. And solving for AY, we're going to have WL over 8 as our solution. And then for our CY, simply have to sum the forces in Y direction. We're going to have WL over 2 negative, and then positive WL over 8, positive CY, all equals to 0. Moving WL over 2 and the positive WL over 8 over the other side. I'm going to take the LCM. You're going to have 4WL, 4W over L over 2, and then for W over L over 8, simply W over L. All equals, and solving this, we get our solution as 3WL divided by 8 as a solution for CY. Once we have that, now we can proceed with our moment and shear diagrams. So we're going to begin with the shear. So shear will begin with AY. So AY in this case is going to be some number positive here, which we can say WL over 8. And then there's nothing going to happen for distance of L over 2. And at that time, we're going to come down by WL divided by 2. And we can assume it's going to be something negative, WL over 2. So when we take WL divided by 8, take away WL over 2, we're going to have our value of this point here at value below 0. It's going to be negative 3WL over 8. And our curve is going to be first order. And then our CY, which is positive 3WL divided by 8, going to bring us all to 0. Okay, and similarly, for our moment's going to begin at 0. And then for this positive area, we're going to go up in a first order curve. And then for this area, till here, which will be our maximum as well, we're going to have concaving downward second order curve. And then for this negative area, we're going to concaving downwards, and it's going to bring us down to 0. To draw the shear and moment diagrams for the beam. To begin, let's find our reaction forces, AY and BY, which is simply going to be, because this beam is symmetrical, going to be 200 times 16 divided by 2, and it will give us both AY and CY, BY, which in this case is going to be 600 pounds on each of these beams. Okay, and once we have that, we need to recognize that the point loads for this beam is dependent on these latitudinal beams here, C, D, E, F, G, and the load for C and G is going to be 400 pounds each. And for the center ones, it's going to be 800 pounds each. Now that we have all the required forces and the reactions, we can draw our shear and moment diagrams. We're going to begin with shear. So for shear, we're going to begin at negative 400, and then we have positive 1600. So we're going to begin at 1200. Okay, this is our 1200. And then there's nothing happening for 4 feet. Then we're going to go down by 800 pounds, and that will bring us to 400. Then nothing happening again for the next 4 feet. We're going down 800 pounds. So I'm down to negative 400. And then from there, nothing happening again for the next 4. And then we're going down again for 400, which will bring us to negative 1200. Then again, nothing happening for the next part, next 4 feet. And then we have positive 1600 and negative 400. That gives us positive 1200. And then we go up to the 0 mark. That confirms our survey is correct. And then similarly, we're going to draw our moment diagram here. So our moment diagram actually is going to be all positive. So we're going to begin at 0 for moment. And then we have this area, which is 12 times 4, comes up to 4,800. So for the first 4 meters, we're going to go upwards to 4,800 pounds meter. And it's going to be first order curve. And then for this area, it's going to be 400 times 4, which is 16. So we're going to add another 1,600 to the 48. And we're going to get to the 6,400 mark. And it's going to be first order curve. And then we have this area, which is going to be negative 1,600. And this will bring us back to our 1,400 mark. It's going to be first order curve. And then we have this area, which is 1,200 times 4, which is negative 800. That's going to bring us to the 0 mark.